Hey, what's going on everybody? In this video, I'm going to show you how I installed brackets onto my CNC to allow me to index the sheets, not only so I didn't have to square them up every time I put them on and off the bed, but it allows me to take the sheets off and put them back in the exact same spot. That way, if I want to pull the sheet back up in Sheetcam, I can still use the remaining portions of the sheet. This should save you a lot of time when loading new sheets. These brackets will allow me to name a piece of steel in Sheetcam if I'm not planning on using the whole sheet. Then I can pull it off when I'm done and put it back in the exact same spot when I'm ready to cut another part from that sheet. All I have to do is open the saved job in Sheetcam, add the new parts to the sheet, and cut them from the unused portion of the sheet. This is what the brackets look like. I'm going to put the files on file share in case anyone else wants to do it like this. I installed these brackets with 1/4 inch self-tapping screws by screwing them directly into the water pan. Just make sure that you're not too close to the edge of the square tubing when you install the sheet metal screws, or you could create a leak in your water pan. There's going to be 2 versions of the file on FileShare, one with 4 parts and one with 3 parts. I use the 4-part design in my shop. Because I don't have a sheet metal brake in my shop yet, I found it really difficult to bend the fingers up at 90 degrees on the 90-degree piece and still have them be 90 degrees of each other also. If you use the 4-piece design, you can easily put them in a vise and hammer over the fingers. In the final design, I modified the space allowance for the slats to give lots of extra room. However, if you use the 3-piece design, you may have to modify the DXF and move them to where they actually fit your machine, because it's going to be really dependent on how your sheet ends up lining up. Okay, the first thing you got to do, get your sheet up here on the bed, try and line it up the best you can. But the next thing you need to do is you need to jog the system all the way to the back, home it. And then once it gets to that far back left corner, go ahead and run the Z-axis down where it's almost touching the plate. You can get really close because it has that spring in there, but that's how we're going to line up our sheet correctly. You can see right here, I have the tip spanning the edge of the material. Try and get in even closer so you can get a better look. Okay, you're going to want to come down to where your machine's sitting at the home position. You want to try and line up this corner of your sheet with the tip of your plasma the best you can. It doesn't have to be extremely close, but like within 1/8 of an inch for sure. And then, okay, we're going to switch around. Now we're looking down the other side, and you can see we're pretty squared up on it. The next thing you're going to do is you're going to run into the other side of the machine. You want to make sure your nozzle's up enough if you put it all the way down to try and sight it in. You might want to slow down when you get close to the machine limits. It should stop itself, but we don't want to crash it. Alright, now let's go back there and look, see how we did. Okay, you can see we're pretty close. Let's move a little bit closer so we can really tell. I can see it from here, but I'm going to put it on the camera. That's about as close to center as we're going to get, okay? So, now we're going to go back to the front of the machine. It's hard to tell from this perspective on camera, but my machine is square. My bed pan is about 1/8 of an inch out. So when I measure it, that gap that you're looking at, in the front it's 1 inch, and at the back it's 1 1/8 inches. And if you come over here to this other side, you can see that it's hanging over on the front and it's not on the back. The machine's square, but the water pan is not square to the machine. It's out a little bit. And if you look back there, I don't know if you can see that the nozzle hangs over the edge of the sheet by probably 1/2 inch from the center. Now we're going to run it back up to the front. Alright, you see it hit the machine limit? That's what that little yellow box is right there. So let's go back over and look at this corner. You can see it's about 3/8 of an inch in on that corner, that side of the sheet. And it's about dead center right there. Now let's go to the front left corner. Alright. Hit the machine limit again. We're a little left to center, but not by much. We'll move around to the other side. And you see our nozzles right there at the corner. Alright, now what we're going to do next, we're going to go to the computer and we're going to cut out the square file. Okay, now that we're at the computer, we're going to go ahead and open up Sheetcam. And we're going to go over some basic flow processes for making your parts as well. So the first thing you want to do when you open up Sheetcam, it just opens up whatever you last had it set at. Sheetcam always does whatever it did last. The last time I used Sheetcam, I had it set up for a 4-foot by 8-foot piece of material because I mostly cut sheets. So if you wanted to change that, you go into options, job options, you can change the size. All right, we're not going to do that. Also, now if you want to open up a template, yes, there it is. Okay, this would open up if we were working in a different size sheet. Like I have a half a sheet of 3/16 plate because I cut the other half out. So if I wanted to start it out, I would come in here, go to job options, change it to 48 by 48, and then it would be more representative of what I actually have on the plasma. All right, let's go back to the beginning. So we have our template open. That's great. What we need to do is the file that I'm going to upload to file share, we're going to import it and turn it into a part. New part, yes. Bed square. Inch should be correct. That's it. This is the file that I made. You may need to open this DXF and change this. Okay. And what this is the 90-degree square we're going to cut. This is another slat that's going to go further down the bed. This slat's going to go further in the x-axis. We're going to go ahead and set up our operations for this and save it as a part. Now this text that I put here, this is to mark my particular sheet. So when you're starting a new sheet, you can, whatever part you're going to cut first, go in, change your DXF, find a spot out of the way, and mark it. Go ahead and say what size it is. I only have hot rolled, so I know that's what it is. And this is number 1 for the 14 gauge. So when I come back and I want to cut some more stuff out of this, I can reload that sheet. That's the most important thing. So we're going to do our operations real quick. This is how I do mine. I put everything on my DXF in different layers because I want them all to be on different layers when they cut. See, right now, Sheetcam has no idea what to do with this because everything's on different layers. So everything feels like an outside cut because these are on a layer by themselves. It doesn't see this one, right? It doesn't see this because it's on a layer by itself. So there's no outside box in this layer, so it thinks everything should cut on the outside. But we actually want this one to cut on the inside. So this is the way I do my layers, the way I organize them. Outside offset, outside layer, 14 gauge, fine cut. That's what we're going to do. 200 inches per minute, that's right, for my Hypotherm 45. We're going to arc in and out, hit OK. That one's done. Go to the next one. Inside, inside. We just used this. We know it's correct. Hit OK. Now you see that this is filled out. And we have the outline. Now we need to do all these score marks. They're actually tiny boxes that I drew, but it doesn't matter. I was trying to put a little bit bigger curve in there, but when we do our operation, we're going to do no offset, so it's not going to really matter. I always call that layer the score layer because that's what it's going to do. It's going to score a line right there. And it should be about the width of a curve. What we are going to do is we're going to take our lead ends out. Well, let's just leave those. We will get an error saying that it can't do it, and then I'll show you what that means. There we go. This is the first error. It's on the inside. This is the one part that is too skinny to have a lead in or a lead out. No worries. Generally, right here, it highlights all the ones that it can't do a lead in and a lead out. Those are all white now. See, it went from the path. It highlights them as a white. It's like right here, it makes it white. All right. Now I'm gonna jump out of here real quick and I'm gonna go fix this. It looks like I'm missing a piece of my box. So I'm gonna go fix that in the DXF and I'm gonna be right back. Okay, now we're back. I fixed this. I got rid of the portion that was missing. Did that real fast. Now we're gonna go. We've done all of our operations. What's important here is that you don't have do your outside offset until last. And you can just move these around and it changes the order in which they'll cut. So as long as outside is last, and I like the score to be first, that's how we're going to have it. Now, you see this, the reason I like these on different layers is because then I know where the error is. See? If they were all on the same one, it makes it harder to find. All right, now we can fix this easy enough. We'll go into the score. We're going to take our lead ends out. Now our error is gone. There's nothing we can do for this error. It's not going to fit anything in there. Another thing, anytime you need to put text like this just to label something on your sheet, if you look up a Stencil font, it comes already ready to go. You don't have to worry about messing with it at all. That's what that is. That's the Stencil font. All right, now this part is done. We're going to call it done. So we're going to come here. Save part as. And we're just going to name it the bed square part file on the desktop. And every time you do this, you want to go in here and you want to put your settings. So this is 14 gauge, 45 amps, fine cut, standard, speed. Okay. And that way, when you're looking through your parts, just in case you have a part that you may cut on a different sheet of something, especially some of the stuff we're going to put in a little bit, some of the filler, the stuff you can use to take out the spots in your skeleton, you want to know what that part's set up for. You may have changed one to 14 gauge, one to 16 gauge. You need to put whether or not you're using fine cut or regular. And then we're going to go ahead and save this real quick. All right, now you see right here, it took our part that we imported and it made it the name of the job. So we're going to close this, and we do not want to save this job right now. No. We'll say yes. We didn't make any changes, but it shouldn't make a difference. We're going to come back, reopen Sheetcam. Still in our 4x8. That's great. We're going to come over here. We're going to do a new part. Yes. This is a little test piece that I'm making. I want to cut it out. I like to do my score first. None, that's right. Those are good. All right, then next, we're going to do the inside. Inside. We've got to put our lead ins and lead outs back. All right, then we're going to do the last one. We're going to do the outside. All right, this part is done. We're going to save it. So we're going to open up a new part. Import our drawing. Let's do the cardinals. I'm sure you're going to want to make these separate files. This is off of file share, and these are just the decorative tree stakes. But I want to cut them out for the first time, so I'm going to, just to see the size and check them out and see if they stick in good with 14 gauge material. So this, I left this like this so you can see it. I left this all on one layer, and this is Sheetcam deciding that these are inside, right? And these are outside. So it did. It correctly nested these all the way. So that's one thing. But when you have an error, it can be hard to find it. And these are just some small shapes, and it'll just not have a lead in, or the lead in will be shortened. So this is fine too. So we're going to save it. And we can just close out of this. No, we don't want to save it. So now we're going to go back into Sheetcam. And we're going to open up our job template. This is our 4x8 sheet, just like we talked about. Now, I want to save this job as, I'm going to save this job as 14 gauge number 1. So now we're going to start adding parts. File, open part. Do this one first. You see it imports with all of our stuff already set up. All right, that's great. Let's do another one. Okay, now here's another part. It always wants to drop it right down here. The easiest way to do this, turn the other vector off, come over to the nesting icon, or looks like a move icon and everything else. We'll scoot that out the way. We'll turn this back on. Now we can go add another new part. Do the paint can. Sometimes it can be hard to grab onto these things. All right. Turn our bed square back on. It turned white, so we have a hold of this. If you come down here in this corner, you see you can set the position or the rotation here. And the rotation is absolute. So if you add 90 and then you hit 90 again, it doesn't do anything because it's not going to increment. If you hit 95 rotates it another 5 degrees, but it's always relative to the how it came into however it was in the DXF. You know, the scoot this down. Just leave a tiny bit of room. Come on. There you go. Make sure none of your lead ins, lead outs are touching. Now, here's the most useful part of this whole thing. All right, we have this sheet open. We named it 14 gauge number 1. We're going to cut that right here into the sheet so we'll know what this sheet is when the skeleton's sitting on the side of my CNC. Because I've switched to another sheet to cut something else out, I'll be able to pull this back out, index it back to the bed, and then be able to add more stuff to this sheet. The easiest way to do that is you turn these off, you come in, open parts, you can do whatever. You can add any part that you already have made. Zoom out, grab it. Tool paths are already made for it. We just need to nest it. So we're going to turn these back on. Come on, grab it. We'll drag it over to the edge. And now this part's already cut out and we already know where it is relative to the machine. So we don't have to sit there and play with it, trying to get it as close as possible. And what's great about this is you can take little things like this and you can fill out your skeleton. Once you have this one new part there, you can turn that one off, and it'll cut this, and this stuff is already cut out. And you can keep adding parts as you go, and you'll be good to go. What we want to do, and what's important, is whenever you go to post-process, it is going to post-process and make a tap file for whatever you have on. So if you have all 4 of these on, it will make a G-code file for all 4. All right. So whatever you have selected, that's what's going to kick out in the G-code. So we're just going to leave these 3, go to File, run the post-processor, fine cut, 45 amps, first 3. So that way you'll know that this particular G-code is just for these first 3. And then when you come back and you add 4 more, you can put 3 through 7. And that way you can kind of keep track of your tap files and keep a good accountability of which one you're actually using. Because I don't like to throw things away. I just put them aside in case I want them for something. So let's go cut this out. All right, guys, we're back out at the machine. Got the thumb drive in. I'm going to come over here. I'm going to load the program. First 3 parts. All right, they show up in the bottom left corner. That's great. We want to home the machine first. Okay, now we're home. Let's go back down to the screen. That's where we are, right here. This is where our stuff is. That's all great. We don't need to zero all the axes. It already knows where everything is. We're going to take this Z axis and we're going to move it up. All right, everything looks good. So I'm going to go ahead and cut. All right, guys, we got everything cut out. The square came out good. Got my 2 side plates, they're good. I'm gonna go clean these, sand them, wire cup them, paint them, and then we're gonna come back and bend them. you'll notice that there's some mistakes made. There's several versions of the bed square that got cut because one thing didn't work or the other. But another thing you're going to notice is when I started cutting my files, I cut them in the front left corner. That was a mistake. You should always put your first files in the far right corner, furthest away from the bed square. That way, as you work forward and you nest your parts, you'll be able to remove the wire frame from the stuff that you cut out, and that way you don't have to load it on and off of the machine multiple times. You can just take whatever usable piece you have left, pull it off the machine and set it aside. That wire frame can go in the trash, recycling, whatever. And then whenever you're ready to use it again, you just pull it back up. Another thing to be mindful of is when you're cutting your parts out of that sheet in Sheetcam, you need to try and stay to the right and as far back as you can, because the further forward you come and the further to the left that you go, the chances of you losing your reference surface gets greater and greater. So you need the front and the left side to be able to index your sheet back into the exact same spot. The smaller the sheet, the less it matters, but if you were to cut out the entire left side of the sheet, then it no longer references the square corner. This is what the brackets look like. I'm going to put the files on file share in case anyone else wants to do it like this. I installed these brackets with 1/4-inch self-tapping screws by screwing them directly into the water pan. Just make sure that you're not too close to the edge of the square tubing when you install the sheet metal screws, or you could create a leak in your water pan. There's going to be 2 versions of the file on FireShare, one with 4 parts and one with 3 parts. I use the 4-part design in my shop. Because I don't have a sheet metal brake in my shop yet, I found it really difficult to bend the fingers up at 90 degrees on the 90-degree piece and still have them be 90 degrees of each other also. If you use the 4-piece design, you can easily put them in a vise and hammer over the fingers. In the final design, I modified the space allowance for the slats to give lots of extra room. However, if you use the 3-piece design, you may have to modify the DXF and move them to where they actually fit your machine, because it's going to be really dependent on how your sheet ends up lining up. And they're very stiff. I don't anticipate them flexing when I load sheet on and off of the CNC. I suggest cutting the brackets first. If you found this helpful, please consider liking and subscribing. I'm going to continue to make CNC videos as I continue to learn more about this plasma CNC machine. If you have any questions or concerns, please leave them in the comments below. Or if you think this video is great, let me know. Thanks for watching.